understanding the economic advantages of a hybrid cloud environment. We are proud to share with you our mix between experience and innovation with the EYP Mission Critical Facilities webinar series. All of the webinars will take place in November. Each webinar will cover a different topic that we believe will be relevant to you on your day-to-day experience, your strategic planning, as well as your cost effectiveness. With a successful start last week, we hosted a webinar about data center sourcing for enterprise organizations and institutions. Today, we will cover our second webinar. The topic will be about understanding the economic strategies of a hybrid cloud environment. On the week after Thanksgiving, on Friday the 30th, at the same time, the third webinar will be about operate your data center effectively, which will be focused on ensuring availability and minimizing expenses in your data centers. As an extra note, the attendees on each webinar will have the eligibility to receive one IEEE continuing education credit per each session. To obtain a certificate, you may request it in our chat room by posting your name and email, or you can also send us an email to info@eypmcfinc.com. And after filling out the questionnaire, we will be sending you the certificate of completion. Next slide. We would like to welcome our speaker, Derek Neese. Derek has over 20 years of experience supporting every facet of facility and technology design, strategy, and implementation. As an integral part of the EYP's data center strategy team, Derek has led data center strategy and consulting projects for several years throughout the US, Latin America, and the Middle East, and brings a broad range of business experience, including IT, finance, and data center operations to clients across higher education, manufacturing, government, and financial verticals. Derek received his undergraduate degree in economics from Occidental College and his MBA from University of Washington. He's also an AWS or Amazon Web Services certified cloud practitioner. For those who don't know our portfolio, next slide please, we also offer the complete solution, including design services, integration, commissioning, feasibility studies, and energy. In this presentation, our focus would be in our strategy service line. Our strategy group has performed over 500 data centers strategic engagements, including roadmaps, data center sourcing strategies, co-location studies, site selections, and data center consolidations on both IT and facilities. If you have questions like how to be more efficient when comparing a traditional environment to a private cloud and a public cloud environment, what are my costs between in-house and multi-cloud environment? How can I create and convince my team to build a data center strategy in my organization that contains a strategic mix between on-prem, co-location, and cloud? Well, you're in the right spot. So let's begin with our understanding the economic advantages of a hybrid cloud environment webinar. Thank you, Derek.
Thank you, David. As the title states, we're going to look at the economics of the hybrid cloud, and we're really going to try to understand and show what are some of the inherent advantages that can potentially reduce the costs of your data center and IP or IT compute environments. But to start this, we really have to think about some definitions, because in the media and all the buzzwords out there, the word, especially hybrid cloud, gets used for a lot of things. So we will first define the traditional enterprise environment, private cloud, and hybrid cloud, at least with respect to what we're talking about today in this presentation. Also, we will look at these three environments considering two sample cases. First is a very simple two-application company, so we will see exactly what's going on with respect to how these environments affect the underlying requirements of IT equipment. Then we'll take a step back and look at a little broader enterprise case to try to understand exactly what it would look like for an entire enterprise across these three different environments. Then we'll quantify the costs associated with these cases. And then finally, we'll take another further step back and look at how it fits into the overall total cost of ownership of both your IT and data centers within your organization. And unfortunately, there are some caveats because there are a lot of cost savings that can be had, but there's no guarantee, and it requires some implementation controls that need to be addressed before you can achieve those savings. So let's get started. First, let's look at the different environments that we're talking about. Okay, traditional enterprise. I first want to call attention to the blue box. And anything in the blue box is company dedicated IT assets. And so that means assets that are not shared between other companies. It's completely dedicated. I might call it on-prem throughout the course of the presentation, but it could also be in a co-location cage or space, and it could also be in a dedicated managed service environment. But the point is, it's not shared. Secondly, let's look at the legacy gear. A lot of people talk about the hybrid cloud. Oh, it's a hybrid cloud because I have legacy gear. But really, the savings that we're going to talk about today don't have anything to do with the legacy gear, because whether we're looking at traditional enterprise, private cloud, or a hybrid cloud environment, those AS400s or old Sun boxes, they're not really going to enter into this this concept that we're talking about today, except if they were upgraded and added to the virtualized environment, which is really the focus of our conversation today. And I want to be clear about what I mean by the virtualized environment too, because we have people from a lot of different areas of expertise, from facilities professionals to IT professionals here. So let's just blow up a little bit what we're talking about by the virtualized environment. We are talking about physical servers, usually referred to as ESX servers, that are hosting all of your VMs or virtual servers that can be many different operating systems. But it's really both these physical servers and virtual servers that I'm talking about when I refer to the virtualized environment. So as you need more virtual servers or fewer virtual servers in any of the examples, that's really going to affect the virtualized environment and both the number of virtual servers and, as a consequence of that, the number of physical servers that are needed to host those VMs or virtual servers. Okay, back to the traditional enterprise. In this environment, we're really talking about traditional deployment methodology where a business unit or an application owner will request their virtual machines of a certain quantity of memory and CPUs, and it may take a while, a few days to deploy that. But the key point is it's kind of sticky. Once it gets deployed, it stays deployed. And so it doesn't get decommissioned when it's not in use. And so what happens is there's very little sharing of VMs across the enterprise. Of course, the hardware is still shared because you share a common hardware to host all of these VMs, but once the VMs get deployed, they're not very agile. Okay, now let's talk about the private cloud. The private cloud is very similar with one key exception, and that is cloud orchestration or cloud management software is added on top to improve the allocation or deployment of these servers to make it much more agile and elastic. A couple items here that are important. Number one, It's self-provisioned, so those needing it can go to their interface and request it in the same way that you can go to any of the public cloud and request a server. The deployment of these virtual machines is elastic and automated, and that means it can also be code-driven. So for example, if one application is requiring more than 80% of its CPU for more than 5 minutes, it can automatically provision a second. And even more importantly, it can terminate those instances if the usage is low. So you get a much more efficient and only allocated when required for each of the virtual machines. The last item is metered consumption. And that is very important because that's part of the governance that is so important to make this work and avoid over-proliferation of virtual machines, which could negate any potential savings. So in addition to metered consumption, doing chargeback and providing incentives for each of the users to control their demand and minimize it for the resources that they need is very important. And all of this is done, as I mentioned, through this cloud orchestration software such as OpenStack or IBM Cloud Orchestrator or half a dozen others that are out there on the market. And finally, the hybrid cloud, we're really defining here as again, the same thing, but the key point here is you can have a much smaller footprint of your physical and virtual servers dedicated to your company because you're no longer worried about the peaks. Those peaks can burst up into the public cloud, and you can easily get by with a far lower quantity within your own dedicated assets. Note also that the legacy gear is the same in each of these environments. So really, again, it doesn't enter the picture. All right. Now, let's look at a couple examples to understand why that reduction can be possible. First, we're going to look at a very simple hypothetical company that does tax preparation software. And let's just imagine looking over the first 6 months of the year, they really only have two applications. They have the sales application and they have the tax preparation application. And in this case, prior to the filing deadline in April, sales is very busy and they have their peak usage of 5 virtual machines in February. And the tax prep guys, they have their peak obviously in April because everybody's trying to get their tax returns finished and completed. But because sales doesn't give back those VMs, once they get deployed, they stay deployed, we end up having to have 13 virtual machines deployed because we have the max for each application when no more than 10 is ever used. And the key problem is there's poor sharing of those resources within the enterprise. So now let's introduce the private cloud. Here we have the exact same loads and the exact same usage, and in all of the examples we're going to be considering the same requirements or the same processing, and all we're talking about is how it can be done with fewer resources in each case. So in this case, because sales can give back those VMs, they automatically get terminated and decommissioned and go back into the pool after their high usage moments. Then we really only have to consider the peak month of usage. And in this case, you can see that we will require 10 virtual machines in April. And so what's the net effect? We are doing the same work with only 10 virtual machines just because we're moving them around and having much more efficient use of those virtual machines and, of course, the underlying hardware. And finally, if we throw in the hybrid cloud environment, again, we have the same usage by month, but In this case, all we're going to do is we're going to have our average usage on premises because we're not really worried about the peaks anymore. We're only worried about our average usage. So you can see on premise or dedicated to us, we have 7 units. And we only need to burst into the cloud in February and April. And the interesting thing, because we're using on-demand resources in the cloud, even though we have peaks of 1 and 3, we only have to consider the average number because we don't pay anything if we're not using the resources in the cloud. So again, here we only need to pay for the equivalent of 8 virtual machines versus 10 in the private cloud and 13 in the public cloud. And I realize this is a little esoteric, and some of the facilities people, I ask you to stay with us because really this is what ultimately drives the requirements in the data center, and we'll bring it all back to that soon. So bear with me. Okay, now let's look at a enterprise-wide view. And if we look at this graph, we can see the number of virtual machines required by week. And you can see we have a peak of 900 in approximately week 10 or 11, and a few other peaks. Our average usage is 691, but we still have to have and pay for 1,000 virtual machines, more than we're ever going to use. And that doesn't look very intuitive at all. It's like, why would we ever have to have so many more than we're ever going to use? But the answer goes back to that traditional enterprise. You can see in the very first group under the traditional deployment, we never use more than 10, but we have to have 13 deployed. So that's phenomena is what's driving this view. It's sort of a gnarly formula at the bottom, but we're really looking at the peak week usage of application A plus the peak week usage of application B for all of your applications. And it's not necessarily the peak month of usage. And that's why we get that loss. And the degree of this waste is really driven home because all of the space under the orange VM provisioning requirement and the usage is really wasted IT resources. I should note also that we are talking about virtual machines here used to illustrate the concept. And VMs are something that most people are familiar with, but this same concept applies to storage or microservices instances. The key is the sharing of resources that's possible through the private and hybrid cloud. And we're just using the virtual machines as sort of a proxy to show that. Anyway, jumping back to the private cloud, what we can do here through that improved sharing and decommissioning when we're not using it is drive down that requirement from the 1,000 units to 900 units. So in this case, we only have to pay for 900 VM licenses and the underlying hardware and physical infrastructure, space and power for 900 instead of the 1,000. Still a fair amount of wasted IT resources, the space again under the orange line, but it's a far less. And finally, in this case, in the hybrid cloud, you can see again we are using 691, or we are provisioning 691 on site and just burst at those peaks when we go over the orange line. And in this case, we're paying for 691 in-house, and the average usage in the cloud is 38. Even though we're getting them on demand, we really need to pay for the average amount that we're using priced at the on-demand pricing within the cloud. But still, you'll see it's quite a bit of savings possible. And I'll show that here on the next page. If we look at the VM provisioning requirements for each one. We've got 1,000 VMs for enterprise, 900 for private cloud, 691 for the blue in the hybrid cloud, plus that average bursting of 38 in the orange part on top of the bar. Now, it's a little difficult to come up with the pricing for a VM all-inclusive in a data center because you have to think about all of the facilities costs and IT costs and staffing costs, as well as the licensing costs and everything else. And as a proxy for that, I just used the cost of a reserved virtual machine, a medium-sized virtual machine in AWS, because in theory that includes all of the facilities and IT hardware and staffing that they have to have in their data center, etc. And so if it's $739 per year per server, that comes to $739K. And if we get rid of 100 of those servers, it brings us down to $665K. And then in the hybrid cloud case, we pay that same value for the virtual machines in-house. So that gives us about 500K, just over that. But then we have to add the average number of VMs that we're using on demand in the cloud, but that's a higher price per instance. But even so, it's really not that many units, and we have to pay 544. So we're really saving a pretty big percentage throughout this. So far, all the focus has been on this IT gear that were our savings, but let's talk a little more about how it fits into the overall total cost of ownership. Each of these shows the major components of your total cost scenario for your IT and data center. And we have shown how the IT hardware costs can decrease and how the software licensing costs can decrease. And of course, there's a corresponding increase in the public cloud. But what's important as to whether the height of these bars decreases or increases has to do with the amount of governance that you can put in, and to ensure that the public cloud is efficiently allocated and efficiently used. Otherwise, you'll have proliferation of the public cloud costs. Just as an example, we worked with a major university recently, and one anecdotal story that they had was they opened up Amazon for running simulations in one of their engineering classes, and they quickly ran up $50,000 worth of AWS costs for one class. And that's just sort of a perfect example of inadequate governance and uncontrolled usage. Also, there are a lot of one-time costs that have to be considered. You have to implement the cloud orchestration software and management. There can be migration costs. There may be additional staffing required for the governance and implementation of that. And of course, application transformation, which is sort of the big animal that prevents the legacy applications from joining this party so quickly, as well as there may be upgrades even within your virtualized environment if there are operating systems that are not supported in the public cloud, etc. And one thing I also want to highlight is the problem of fixed versus variable costs, because we've been talking about how you can reduce the number of virtual machines you need, and in that case you'll probably reduce your operating system licenses and some power and things like that. But a lot of those costs that are fixed and support that hardware are not going to go away right away. Think about server hardware. Perhaps you have a 4-year lease on that, and you're working very hard to reduce that virtualized environment footprint, but those costs aren't going to go away until the lease is complete. Same with that ESX storage array that's sitting in on your data center floor. That's going to continue to have its spinning disks and occupy space and generate heat until you get rid of some threshold of virtual machines and requirements. So you have to think about what is the moment that you can actually reduce these costs. At what point can you offload enough things out of your data center and consolidate your virtual environment footprint such that you can consolidate a data center, get out of a data center. And you have to be careful when you use the big cloud providers' total cost calculators, because they will ask you about your data center costs and all of your hardware costs and compare it to what they are charging. But they don't really have the information on when your fixed costs are going to be reduced. And so they're just going to say, if you get rid of 10% of your servers, we can assume that you're going to get rid of 10% of your costs. It's sort of a necessity because they don't have that information, but it's also perhaps in a cloud provider's favor to not show that these savings might not be realized until you hit some threshold in the future and it takes a step down. There are a few other things that can go wrong, and that is, we've mentioned inadequate governance. You really have to have the appropriate approvals and standards to prevent out-of-control usage, and if possible, implement incentives so that each user or department actually faces the cost of the IT resources that they are consuming. Another item to consider is that in the private cloud, you may not have all the same features that you have in the public cloud. There's lots of very specific extras that they have in the private cloud, like Amazon's recognition for video and image recognition, or their proprietary database, Aurora. And so you really need to be careful. If you look at Azure Stack, even, that is probably most closely tries to replicate the public cloud in the private cloud, it says right up front that not all services offered in the private or in the public cloud are available. So you just have to be careful and make sure you're aligned on that point. Also, chatty applications can drive up networking costs. In the cloud, you usually don't pay for what you put in, but anytime you access it or have to take it out, then you're paying a transfer cost. So you need to think about how much your applications are talking, where their dependencies are, where are the databases that they're accessing. If they're running in the cloud, are the databases also in the cloud, or are they still on-prem? All of those things can create some nasty surprises, so you need to be careful with that. And finally, legacy apps, which we have talked about before. There is no hybrid savings for them until they get replatformed or refactored, which is quite costly. So I guess the takeaway from all of this is that there's money on the table here. There is savings to be had as you go down this path, but you have to be very careful that it's implemented with the appropriate controls and the appropriate governance, and for those savings to be realized. And also just be aware those savings may not come immediately. They may come stepped and in the future. So the last thing I just want to talk about is really, how does this cloud analysis fit into the overall data center strategy? And in our case, when we're performing a data center strategy or sourcing for our customers, we are looking at the main inputs, capacity and cloud adoption, which really go very hand in hand because it's essentially one alternative to having capacity in-house or in the cloud. Coming up with the technical requirements or business requirements for tolerance for downtime and latency restrictions. There may also be non-technical constraints such as regulatory issues or company tradition, things like that. And finally, financial inputs. That's both financial constraints as well as all of your existing leases and expenses for both the IT and facilities equipment, etc. And with these, we generate several different scenarios to look at what are the potential data center options to use, whether it's co-location, on-site, or in the cloud. And usually there's 2, 3, or 4 different scenarios where we're looking and quantifying the contents of each site over time and coming up with the corresponding year-by-year CapEx, OpEx, and cash flow. And that really includes the cloud costs and the savings associated with that come at different times in the future, as I had mentioned. So I think that really sums it up for me. I think we have some time for questions. I don't know, David, if you have collected any.